Process of a Star by Kieran Van Horn. Okay, so to first start a star, it's all a bunch of dust and gases and miscellaneous. So to create a nebula, it's dust and gases that first are separated and then they come together. So what the nebula looks like by the end of that process is that it's a bunch of dust and gases, hydrogen and a little bit of helium here and there, and it's just like a big clump of like miscellaneous like dust and poof. To create a protostar, the dust and gases have come together, and they come together by bumping into each other, like the atoms keep bumping into each other. So it goes bumping, and then the bumping creates friction, and so the friction creates heat. So you go bumping and friction to heat, and bumping and friction to heat. It goes over and over and over. So what the protostar looks by the end of its process is like it's like a big poof air gas cloud with like a small circle in the middle because it's the creating of like the first early stages of a star. And so after the bumping and heating and stuff, um, it's starting to turn into a star, like the cloud of gas is turning into a star. Now, to create a main sequence star, the atoms still have to keep bumping into each other and to create friction and then to create heat because it has to keep going and going and going so the stars can like keep going on and on and on. There's more stages that go on and the process goes on. So to create a main sequence star, the hydrogen atoms are forming into helium ones, and a main sequence star is pretty much our sun, so it's like an average size but also not like a giant size. By the end of the stage for the main sequence star, it's the atoms keep bumping into each other to create friction, to create heat, and then it gets bigger, like the core of the star gets bigger. And then as the star gets bigger, the core is starting to slowly turn into a helium core because the hydrogen atoms keep bumping into each other, and then it's creating helium atoms. The next thing in this process, the star can either go to a red giant or a red supergiant. Right now we're going to go to a red giant, and it's one of the giant stars, and like it's a dying star in its last stages of star evolution. And this one, it's still having the bumping and the friction, the heat, and the core is still getting bigger, but it's out of hydrogen atoms, so it's all a helium core. And with the helium core, it's trying to exfoliate all of that, so then it ends up turning into a dying star. So the red giant end, it has all the hydrogen atoms. They are gone. They are gone out of the star. It's all a helium core. It's only helium atoms, and it's trying to exfoliate all of them. So the star is huge. It's giant. That's why it's called a red giant. Planetary nebula comes after the red giant, and it's pretty much just like expanding a glowing shell of gas ejected from the red giant. So like it's going to be like a new phase. It's a nebula, just like a planetary nebula though. So it's like dust and gases and starts a process all over again. By the end of the planetary nebula, it's all dust and gases separate again because the red giant has died. It didn't explode. It just kind of just goes poof, and then it's gone. So then it's like all the dust and gases separate again. It's like the nebula towards the beginning of this process. After the planetary nebula, it goes into a white dwarf. So it's a very, very tiny star. It's very, very low mass. It's like really tiny, but it's really bright in the sky. Like it's brighter than a red supergiant would be because it's tiny and all the dust and gases have come together, but it's just like a little tiny dwarf. So after the white dwarf, it can eventually go into a black dwarf, and that's an even more low mass of a star, and the light is just out of it because it's just like so low mass and it's teeny tiny, and then it eventually just goes poof, and the process for low mass stars can start again. Alright, now we are on to the higher mass stars. So it starts off the same. It goes nebula into a protostar into a main sequence star. So it goes all the dust and gases, and then they come together. That's a nebula. And the protostar, it's like bumping and friction to heat. So then it's like the dust and gases all come together, and it's like a little ball in the center. And then after that, the bumping to friction to heat, and then it becomes bigger, and then it's like an average star now because it just keeps bumping and bumping and going, and all the hydrogen atoms are come together in a core, and then it forms a star. That is the beginning of higher mass stars. After a main sequence star, it can also go into a red supergiant, so it's even bigger than the red giant we talked about before. It's like 10 times bigger. It's huge. It's a super giant. Come on. And the core is completely helium, like it's already completely helium. So by the end of the red supergiant, it's huge, and the hydrogen atoms keep bumping into each other, which forms into more hydrogen atoms, and then they bump into each other, which creates helium atoms, and so then it's just completely solid helium core, and the star is huge and it's ready to go poof. Except after a red supergiant, it just doesn't go poof; it goes into poof because it goes into a supernova. Now, a supernova starts off as the red supergiant starts to die, so then it all just goes blue, like everything starts to separate before there's a big explosion. By the time everything slowly starts to separate, the red supergiant creates this big explosion. It goes, and like all the dust and gases dissipate and go away, and they all separate. It's all over again, blah blah blah. It's a huge explosion. After that mass explosion, everything collapses, like the star collapses, and then after a star collapses, it can create a neutron star. After a red supergiant goes into a supernova, it can either go into a neutron star or a black hole. We already talked about a neutron star, so now it can either go into a black hole, which pretty much is a hole that sucks everything up, like light included, just sucks everything, and you could die. And finally, after, you can either choose between a neutron star or a black hole on the higher mass process of stars. I'm pretty sure that after a black hole, it goes into a white dwarf, so everything just dies down. Even though a black hole is super high mass and it sucks energy and light in, it goes back to a little black dwarf, and then it can just dissipate whenever it wants to, because it's like back to a lower mass star before the process can start all over again.